Hi friends, welcome back to another interesting tutorial. In this tutorial, what we are gonna do is we are gonna uh, do a custom object training using the YOLO machine learning algorithm, and then we'll use it to detect our commonly used object which today, which is a hand sanitizer or a sanitizer. So for that purpose, what we have done is I have downloaded some images from the open source internet. Uh, they have all different types of sanitizer images like this. They are freely available. This is from a site called Dreamstein. I downloaded around 100 sanitizer images. I also combined them with my own custom sanitizer pictures taken from my Android phone. So let me show you the custom images as well. So these images were taken by me, these only 4 images, just for the purpose of the proof of concept. And I have 3 individual images, one hand sanitizer, uh, and then the 3 of them together. So I have 2 categories here. One is a hand sanitizer category, and then the other 2 are sanitizer category. Same applies to the images as well. So all these are, most of them are sanitizer category. Only one of them I have categorized as hand sanitizer, 1 or 2 of them. So because of lack of time, so what I have done is I have uploaded them in RoboFlow, and I have annotated them, and I have the following training set, validation set, and test set. And for pre-processing, I have auto-oriented them and resized them to the same size, 640 by 640, and some augmentations also have applied, like rotation around 15 degrees angle to the left and the right. And then I have downloaded this images set. Once I did that, I exported it out. I'm using this particular Google Colab notebook where I'm downloading the YOLO from the YOLO repo, GitHub repo, YOLOV5, and then I'm cloning it and I'm installing the requirements using the provider requirements.txt. Once it is installed, I'm downloading the image set that I created on RoboFlow. Uh, Once I download the image set, I'm going into the YOLO5 repo and setting the dataset to YOLO5 dataset location as data.yaml. This has been generated by the RoboFlow thing. So basically it is saying it has 2 classes, hand sanitizer and sanitizer, as I mentioned earlier. And the image folders test, train and validation are already organized by RoboFlow. So then I'm loading the YAML file and changing some of the data in the configuration of YOLO file. So it has 80 number of classes of commonly used objects. It is basically a COCO dataset, YOLOv5. It is supposed to be very fast and very efficient compared to other other object detection frameworks like ResNet, or it is comparable to VGG19 as well. So we are going to override that configuration file with our own thing. The number of classes will be automatically detected from the our image RoboFlow image YOLO configuration. It is 2 in number, it is not 80, and other parameters we are setting up for the YOLO v5 architecture. As you can see, it has convolution layers, and concatenation and other stuff. And now we are going to train our YOLO v5 model, our custom YOLO v5 model, using the different parameters. So img is the image size, and the batch size. I have earlier tried it with other batch sizes. So I think 64 was, I tried it with a batch size of 16, and then I also tried with 120, 125, and then I thought 64 was working well for me. I've tried with epochs like 100, 200, but 1000 gave me better results. And the dataset location, which it picks up from the YOLO, our data.yaml file, and the configuration, custom configuration, where we have mentioned the categories, classes, the weights. So we are not using YOLOV5 weights, so that's the why it is empty, and the name of the location of where we want to store the weights, generated weights file, and cache means we are caching the images. So now what we see is it uses the default checkpoints, and at some point uh, instead of 1000, it at around 600 epoch it does a early stopping. So, and it trains the uh, weights. So then what we do is we use the tensor board and we check certain parameters. We can look at certain parameters. What we see is the metrics. MAP is the overlap, mean average precision, and what we see is it's around 35 or around 40. It can go around 45, 50. Uh, MAP 0.5 means it's average, mean average precision, and this is going, it is also around 25, 30, I think. The precision and the recall as well is around 50%, 40 to 50%. The loss is as per our expectation, it is reducing as the training proceeds. And then we are visualizing some of the training data. So these are the bounding boxes that we already created when we were when we were using RoboFlow. As you can see, it has a sanitizer around the bounding boxes with sanitizer label. So one thing I noticed is that because of the type of images, we are only using around 100 to 200 images. Actually, if we can use more images, the precision and recall, and I think they all will improve and will get more accuracy. Now this is the augmented data, like it is combining two or more pictures, it is tilting them, and there also it is able to, oh, it is showing the bounding boxes. This was used for training basically. Like here you can see there is a cap also, it is identifying. And now what it has generated the weights, the best.pt, and then we are running the detect.py, which means it will detect whether it's a sanitizer or not, and the average speed is 4 milliseconds, which is very fast. That is the reason, one of the reasons why YOLO has a lot of prominence. And now we are detecting, well, now we are displaying the test images. So as you can see, it doesn't detect for all of them, but the precision, the percentage or probability of detection also it is showing around the sanitizer this uh, object. So these were not used for training, these are pure test images, so it is able to detect them. So there are only 5. So now I'm exporting the um, because I'm okay, reasonably satisfied with the results. I will now export this the weights, the custom weights of custom object detection into my Google Drive, and also I'll download it and check it in my GitHub. So if you see, I have put it in my repo here, best.pt. I will also show you in my GitHub repo. So I have copied it in my GitHub repo. So if you want to use it, you can use it. I have the images with XMLs. I have it in the YOLO v5 PyTorch format generated by RoboFlow. Also the images also here in my GitHub repo, and the data.yaml and the IPNB file also that I used in Google Colab. So now what I'm gonna do is I'm gonna copy this. I'm download this on on my Raspberry Pi. I have a Raspberry Pi. I will copy this weight in Raspberry Pi. Also download the Ultralytics YOLOV5 um, official repo, and I will clone it, and then I will run it against using my Pi camera. So for this video, this is what we have. I will try to upload the Raspberry Pi video as well. So see you again soon. Thanks for your support. Please do subscribe.